let me recap what we did so far. What is given is the percentage yield. And we know that percentage yield is actual yield divided by theoretical yield times 100. That much percentage, okay? It is also given that the amount of PCl3 available is 73.7 grams. If you take a look at the equation given, it is a balanced equation. Equation number 1 is a balanced equation. So, but we do not know the amount of components given in terms of moles. We know the amount of PCl3 given in terms of mass. That's 73.7 grams. So we need to convert that into moles. That is the next step. Okay. So first step is to calculate the mass of PCl3, mass of 1 mole of PCl3. Okay, mass of 1 mole of PCl3. That is the calculate that. That is the first step. The mass of P is 31. Meaning, sorry, yes, that's correct. The mass of phosphorus atom is 31 AMU. Okay. Chlorine is 35.3. So we have 3 chlorines, so 35.3 times 3. Right? So you get, when you add 31 and 35.5 times 3, you will get 136. So the mass of PCl3 molecule is 136 atomic mass unit. Okay, what that also means is that 1 mole of PCl3 weighs 136 grams. Okay, don't mix them up. 1 mole of PCl3 weighs 136 grams. 1 molecule of PCl3 weighs 136 atomic mass unit. But in 1 mole contains lots of molecules. So 1 mole of PCl3 weighs 136 grams. Okay. Alright, so now we need to calculate 136. We need to convert 136 to mole. How many moles is 136 grams? That is the question. That is easy to calculate, right? Given that the amount of PCl3 available is 73.7 grams. So all we need to do is divide 73.7 with 136, because 136 is the mass of 1 mole of PCl3. So you get 0.54 moles. Okay, amount of PCl3 in moles is 0.54, right? All right, so now if let's write another equation. In that equation, let's also write down the amount of moles available for the reaction. So the amount of mole available for PCl3 is 0.54. We know that, we just calculated it. So what is the amount of Cl2 required? Based on this the equation, the balanced equation, we know that when 1 mole of PCl3, for each mole of PCl3, we need another mole of Cl2 for the reaction. Okay. In other words, the ratio between the required amount of PCl3 and Cl2 is 1:1. Okay. So basically, bottom line is that we need the amount of PCl3 available in terms of grams is equal to 0.54 moles. Okay, so basically if you write an equation that contains the amount of moles, then you would multiply this PCl3 with 0.54, right? 0.54. Okay, and because based on the calculation that we performed so far, 0.54 mole of PCl3 is available, meaning 0.54 times 1 mole of PCl3 is what is available. So we need to multiply, Cl2 with 0.54 and also PCl5 with 0.54. Okay, so we get this new equation: 0.54 PCl3 plus 0.54 Cl2 equals 0.54 PCl5. Now it is easy to calculate the amount of PCl5 in terms of grams, because we know that the amount of PCl5 in terms of mole is 0.54, right? So in order to calculate that, first let's find out the molar mass of PCl5, the mass of 1 mole of PCl5. So the mass of 1 mole of PCl5 is the mass of P is 31, chlorine is 35.5, and we have 5 chlorines. When you perform this calculation, you'll get 206. 206 is the mass of 1 mole of PCl5. So how many moles is produced? 0.54 mole is produced. Okay, so the mass of 0.54 mole of PCl5 is 0.54 times 206 is 111.24 grams. Now theoretical, what that means is that theoretical yield is 101.24 grams. What is the actual yield? Based on the equation, actual yield divided by theoretical yield times 100 is given, right? That is 83.2 percentage. That is 83.2 percentage. Okay, so actual yield divided by theoretical yield equals 0.832. Now it is easy to calculate the actual yield. Actual yield equals, you just in this equation, you substitute the values, substitute the unknowns in this equation with the values that you just calculated. Okay, now we know what is theoretical yield. Theoretical yield is 11.24, and 83.2 percentage is the percentage yield. So to calculate the actual yield is 0.832 times 111.24, that is 92.55. Okay, thank you.